In this video, we will discuss volatile keyword. When you have two or more threads running in parallel and operating on a variable, there is a good chance that the local copy of each thread has a stale value of that variable. And thread keeps a local copy of those variables for performance reasons. So volatile keyword saves us from this kind of situation. Volatile keyword in Java is used as an indicator to Java compiler and thread that do not cache value of this variable and always read it from main memory. So let's look at this diagram below. So you have this main memory of RAM and you have variables in this RAM. And then you have a threading engine and then you have threads, thread 1 and thread 2. And each thread has its local instance of CPU or this thread is running on the CPU and then its own local cache which has its own variable, and this thread 2 is on this CPU too and has a local copy of these variables. So normally what thread does is that it copies those variables directly from the main memory and keep a local copy and then operate on the local copy. And why it does that is from the performance reasons. So when you define a variable as volatile, then thread is instructed not to make a local copy of that variable. So if this variable is volatile, then thread 1 and thread 2 will not have a local copy of this variable, and whenever thread 1 needs to operate on this variable, it will always look for this variable in the main memory. And the same is case with the thread 2. But from performance side, volatile keywords has an impact on performance. Because every read of volatile variable is from RAM, so don't make a variable volatile if you don't have to. Cache is much faster than RAM, so always try to make sure that don't make a variable volatile if you don't have to. Now in this example, I will demonstrate the use of volatile keyword in Java. So I have created a singleton class, and with the singleton class, as you know, that only one instance of this class can exist at any given time. So in this case, defining singleton instance as variable ensures that every thread sees the updated value of instance. So here you have a variable private static volatile singleton instance. So if we have two threads operating and try to get this instance variable and reading on this instance variable to see if this instance variable is changed, they will make a local copy of this instance variable, and there is a good chance that this instance variable is not reflected in their local copy. So when you define this volatile, it means that thread will always look for this variable in the memory. So here, if instance equals null, synchronize this class and create a instance of this class. So all the other calling classes will call this getInstance method. Now a few more important points about volatile keyword. Variables can be defined as volatile. Methods and classes cannot be volatile. Volatile keyword guarantees that the variable will read from main memory and not from thread local cache. In Java, read and writes are atomic for all variables declared volatile. Java volatile keyword does not mean atomic operation. It is common misconception that declaring variable volatile will make all operation on the variable atomic. You still need to ensure exclusive access using synchronized method or block. So in volatile, when you define a variable as volatile, you cannot expect that all the methods or all the threads which were going to the volatile keyword, accessing the volatile keyword, will be synchronized. Those threads can still have stale value of volatile. It may not be in the local cache, but while doing the operation, they can have the stale value of the volatile variable. So we still need to do synchronize, or we still need to have a log if there are multiple threads who are trying to access that variable. And we'll be seeing this example in our future section. If a variable is not shared between the threads, don't use volatile. Every read of volatile variable is from RAM. Don't make a variable volatile if you don't have to. Cache is much faster than RAM. So now let's look into a use case of volatile keyword. So in the scenario where one thread is writing to a variable and other thread is just reading, like in case of status flag, and we will show example for this next, volatile helps in the correct visibility of the value of that variable. But volatile is not enough if many threads are reading and writing the value of the shared variable. In that case, because of race condition, thread may still get wrong value. Now let's implement an example of volatile keyword in IntelliJ. So let's create a new class in our com.modernjava.threading package, and the name of the class is volatile example. Let's create our public static void main method, and let's define a variable volatile, and this is a boolean flag, and the initial value of this flag is false. Let's create two threads using lambda expression. New thread, so I'm just creating the thread definition first. And now let's look into the implementation. So for we are looping in this thread for integer I is equal to 0 and I is less than 2000 and I plus plus. And we are printing out the value of I. And afterwards, after printing out those 2000 numbers, I am making the flag equal to true. And after making the flag equal to true, I am printing out the value of flag. So I'll be using south v because it will print out the flag value for me. So here I then print out, so let's do the value of flag is plus flag. Now here I am going to define integer variable I is equal to 1, and while flag, not a flag, while the flag is false, plus plus I. So while the flag is false, increment the value of I. And when the flag becomes true, print out the value of I. And the second thread is plus. So here, so new thread, it will wait for this for loop, and then afterwards turn on the flag is equal to true. And while this thread is going in a loop, this thread is printing out I. It's going through it's going basically incrementing I, and then afterwards it will print out the value of I. So let's start those thread. So what we can do here is that we can just put dot start directly over here. You don't have to start the thread using thread is equal to thread, and we don't have to initialize it with the variable. We can just start it directly using dot start. And let's run this program. So you can see that it printed out the values of I from this thread while waiting for flag to become true. And then when the value of the flag is true, it terminated the loop, or it terminated this while loop, and printed out the value of I, and the second thread is I. So this is a good example of volatile keyword. Now let's take this volatile keyword out and run this program again. And let's see what the behavior of the program is. So you can see that thread is still going on because it is not terminated, and it printed out the value of flag till 2000. And the value of flag is printed out, but because this thread has a local copy of this flag, as the keyword is not, as the variable is not volatile, this thread has a local copy of this flag, and the value of this flag is false. So this thread does not know that the value of this flag is changed. So that's why you have to use volatile in these kind of situation. Now let's stop this and make this volatile back. Save it. And let's look at the program which we have done, which is some of the numbers using runnable interface with lambda. And remove this synchronize keyword and make this variable volatile. And let's run this program. So here it is complaining about static. So let's make the static. Let's run this. So here you can see that sum is incorrect. So you cannot use volatile as a replacement of synchronize. As local thread may still have the stale value because of race condition.